Hi everybody, we're here and we are going to start on the second part of section 1 of chapter 1, which is sketching graphs of lines. And today you will be able to use slope-intercept form to sketch linear equations and use slope to identify parallel and perpendicular lines. So let's jump in. Slope-intercept form of an equation of a line is y equals mx plus b. And if you look at the name of slope-intercept form, we know by looking at the name, this is the information that's readily available. Slope is the m. So whatever you find the slope to be or whatever they give you the slope to be, we'll insert for m, which will be the slope. X is part of the equation, we leave that alone. And then B is the intercept, specifically the y-intercept. So we don't put it in as m or b, we put the actual slope or the actual y-intercept in, and y and x are part of the equation, okay? So let's determine the slope and the y-intercept of each linear equation. So right now, the way that it's written, it doesn't look like slope-intercept to me. Remember, slope-intercept is y equals mx plus b. In this form, you'll see that y is by itself. Y is not by itself here. So we want to get it by itself. So in order to do this, number one, we are going to get the y by itself. And we're just going to do that by just kind of moving over x. Since it's a positive 1x, we do the opposite, which is minus the x to both sides. This will cancel. And we're left with just the y on the left side of the equal sign. On the right side, I can write down negative x plus 2. And I put the 2 behind it because I want it to be in this form of y equals mx plus b, which if we look at it now, this is y equals mx plus b. So in this case, m is a negative 1. Remember, when there's nothing in front of a letter or a variable, there's a coefficient of 1 because 1 times anything is itself. And the value for b, or the y-intercept, is 2. So we determined the slope and the y-intercept of that equation. Okay, let's look at y equals 2. So now remember, just to remind you, if we were looking for this, remember this is the x and this is the y-axis. If y equals 2, I want you to think in your head y always equals 2. So where does y equal 2? Well, it equals 1 here, 2 here. So y always equals 2 here. That's a point, but where's the line where y will always equal 2? That means x can equal anything, but y always equals 2. So here's the line, y equals 2. So this is just a reminder to tell you what it looks like. So if I'm looking for the slope and the y-intercept, by graphing that equation, and here it is, by graphing it, I know the slope of a horizontal line is 0. And the y-intercept is b. So where do we look on the y-axis? Wherever that line hits it, that's the y-intercept, so we know that it's 2. Okay, moving on. So now we have it doesn't look very great, but this is our toolbox for all of our equations of lines that we're going to see. Okay, so the first one is, that you've probably seen before, hopefully you have, is the general form, which is ax plus by plus c equals 0. And we use that in different ways. We use that for the cover-up method. We use it for the intercept method that you probably learned last year. And remember that a, b, and c are all different coefficients. The x and the y and the 0 are part of the form that have to be there, but a, b, and c could be any numbers. Okay, vertical line. Vertical line is in the form of x equals some number a, and that's because a vertical line will cross the x-axis somewhere. So for example, if this is the x-axis, let's say we'll call this a. A vertical line will be called x equals a because when x equals a, here's the point there, but we want it to always equal that. X will always equal a, which means x cannot equal anything else. So we draw that line right there. All right, let's look at the next one. A horizontal line is y equals b. So a b could be any number for the value of y. So let's go ahead and look at that on a graph as well. Here's the y-axis, here's the x-axis. So let's just pick a random value for b. And if y always equals b, let's put our dot there. How can I explain that y will always equal b? Well, can y equal anything else? No. It can't equal anything else on the y-axis, so we have to go across right here. Pretend like that was perfect. And that's why we know it's a horizontal line, that y always equals b. And slope-intercept form, we just learned that, remember? It's, what is it? And remember, m is just the slope, and b is the y-intercept. Okay, last one that we've already gone over is point-slope form. And remember, a point, we have two coordinates for that. That's the x and the y coordinates, so we'll call it x1, y1 for point 1. And again, slope is m. So looking for point-slope form, that means the point and slope are readily available in this form. So we'll say that y minus y1, which is this part of the point, equals m, which is the slope, times x minus x1, which is the x part of the point. So remember, if this is x1, y1, and the slope, these go here. When we say x1, that just means some number for that point, the x coordinate of the point. Y1 is the y coordinate of the point. Slope is how steep it is. It's a number. But x and y, here and here, are part of the form. Anything in black is part of the form. All right, let's move on. Let's talk about parallel and perpendicular lines. Now keep in mind, parallel go in the same direction and never cross. Okay, there's a joke and it says, too bad parallel lines will never meet. They have so much in common. And it's funny because they will literally never meet, but they go in the same direction. Okay, and perpendicular is the opposite of that. They meet at a perfect 90-degree angle. So hopefully that looks familiar to you. And the definition of parallel lines are two lines that are parallel. And there's this term that we use in math, and it says, if and only if their slopes are equal. So what do we know about parallel lines? That their slopes are the same, right? And that makes sense because if two lines are going in the same direction, they're going to have the same slope. Okay, so let's look at this example. It says find the slope-intercept form of the equation. So this is my shortened version of equation of the line that goes through the point 2, -1, and parallel to this equation here. So we have some really important information here. So remember, if this is a point, we're going to use this as our x1 and y1. And it's telling us this information is in regard to the slope that we're talking about. So remember, they're asking us to find this in slope-intercept form. Let's write that down. What's slope-intercept form again? So remember, it's y equals mx plus b. Anything in black has to stay there. M and b will be replaced by the slope and the y-intercept. Okay? So here's the thing though, they've given me a point. I don't have the y-intercept. So we're going to use the information we have to find the slope and the y-intercept. So here we go. Let's always look for the slope first. So we know if it's parallel, it has to be the same slope as this equation. So let's go ahead and get this in a form where we can actually find the equation. So if we have 2x minus 2y equals 5, that's called standard form. Let's go ahead and make it so that we can get y by itself so we can isolate the slope. So let's go ahead and put it in y equals mx plus b form. Here we go. I'm going to write it right next to it. And let's get y by itself, so we're going to subtract the 2x. And then divide by the negative 2. We get y equals positive x plus a negative 5 over 2. And we can just leave it like that for now. So the good news is I don't care about everything about this equation. I only care about the slope. Now remember, it's y equals mx plus b so that we can decode what the slope is. So whatever the coefficient is in front of the x, when the y is by itself, that's the slope. So if the slope of this line here is 1, parallel slope to it is the same. So my slope is going to be 1. And the good news is, once we know what the slope is going to be, we don't care about this anymore. It's gone. All right, so we know that 1 is our slope. We're going to put it in here. But now we're still looking for b. We don't know it, but we do know this is a point. So here's what we're going to do. When we don't know what the y-intercept is, we do have a point, which means it's a solution to the equation at that specific point. So for right now, we're going to borrow this value for x and this value for y so that we can solve for b. So we're going to insert the point for x and y to solve for the b value or the y-intercept value. So here we go. Here's y, here's x, and there's m. So we go y is negative 1 equals m, which is 1 times x, which is 2, plus b. Now we solve for b. So we simplify 2 times 1 is just 2, and now we're going to get b by itself. Subtract the 2 to both sides, and we're left with b equals negative 3. So here we go. Going back to the original equation, find the slope-intercept form. Remember, slope-intercept form is right here. Y equals mx plus b. We found the m, and we found the b. So let's write it. Y equals m, which is 1, x plus b, which is negative 3. If I want to simplify that a little bit, 1x is just x, and adding a negative 3 is just minus 3. And there is our beautiful answer. All right, let's talk about perpendicular lines. So perpendicular lines, the definition of perpendicular lines are that their slopes are negative reciprocals of each other. So if their slopes are negative reciprocals of each other, that's basically like saying negative meaning opposite or times a negative, and the reciprocals, we flip it. So let me ask you a question. If the slope is 2, what would be the perpendicular slope to 2? So we know we take the negative and we flip it. So right now it's 2, which is really 2 over 1. So in order to take the perpendicular slope, we would take the negative reciprocal. Okay, let's do the next one. So if it's 4, it's like really 4 over 1. The negative reciprocal of 4 would be negative 1/4. The negative reciprocal of 7 would be negative 7 over 1, which is just negative 7. So these are perpendicular slopes to each other because they're negative reciprocals. Negative 3 can be rewritten as negative 3 over 1. So the opposite or negative reciprocal of that is positive 1/3. And the last one, what's the negative reciprocal of negative 2 over 5? Hopefully you guessed it, positive 5 over 2. All right, now we're ready to tackle an equation of a perpendicular line. This is my abbreviation for equations, and this is our little symbol for perpendicular. We're going to find the slope-intercept form of the equation of the line that passes through the point. Here's our x1 and y1, and it's perpendicular to this equation. Now that equation actually looks really similar. We used it up here. Okay, we used it up here and we were able to get y by itself right here. Y equals 1x plus negative 5 over 2. So let's bring it down here. Y equals 1x plus negative 5 over 2. And because we know it was the same, this is in slope-intercept form, which tells me what information is readily available. That's right, the slope, right? And our goal is that we have to know what the slope is and what a point is to be able to put it in slope-intercept form. So we know the slope for this one is 1. So what's a perpendicular slope to 1? So if the value was 1, what's the perpendicular slope for 1? Well, we know it would be the opposite, which is negative. Reciprocal is 1 over 1, which is still negative 1. So here's our slope. And keep in mind we're using this point 2 comma negative 1, which is x1, y1. So again, we're trying to get this in point slope form, or excuse me, slope intercept form. I don't have b, but I do have m, so I can replace m with negative 1. Remember that y and x are part of it, but because we don't have a solution for b, we're going to borrow this point as a solution for the equation that it will touch. And we're going to plug this in for x, and we're going to plug this in for y so that we can solve b. So here we go, our y value is negative 1, m is negative 1, x is 2, and we're looking for b. So we go negative 1 equals negative 2 plus b. Solve for b by adding 2 to both sides, and we get positive 1 equals b again. So if we're looking for that, we go, if we're plugging it into slope-intercept form, we know m is negative 1 and b is positive 1, which I can simplify that. Y equals negative 1x is really just negative x plus 1. All right, and that's it for notes for section 1, part 2. Right now, go ahead and get started on your assignment just for a few minutes just to get some practice, and we'll finish it tomorrow or our next class.